Hello children, welcome to my channel. So let's solve a question on current electricity in this video. So the question says, in the following circuit, a bulb rated as 1.5 volts and 0.45 watt. The bulb is here, which is connected in the circuit. If bulb glows with full intensity, then what is full intensity? Then what is the equivalent resistance between the points X and Y? So first let us try to understand what is the meaning of full intensity. Suppose there is a bulb, I'm assuming there is a bulb which is rated as 100 watt and 220 volts. This means that if you connect this bulb to a source of 220 volts, then it glows with a brightness which gives you power of 100 watt. And if you connect it to a potential which is less than 220 volts, then obviously it will glow with brightness having power less than 100 watt. So and on the other hand, if you connect it to a source voltage which is greater than this rated voltage 220, the bulb will get fuse, so the bulb does not work. So the connected voltage must be less than 220 or it can be equal to 220. In this case, the bulb glows with full intensity, which means the potential difference across the bulb is equal to the rated voltage, which is 1.5. Since this R and bulb are in parallel, the potential across these 2 points would be 1.5 volts. So the potential across these bulb as well as resistor altogether is 1.5 volts. Now the battery is of potential 6 volts or EMF 6 volts. So let's say the potential across 3 ohm is V1 and the potential across X and Y is V2. We already know the value of V2 is 1.5 volts and the value of V1 should be 6 minus 1.5, which is 4.5 volts, because you can see that the sum of potential drops in a closed loop is 0. So if it is like 4.5 and 1.5, the sum gives you 6, which is equal to the battery. So now using this, we can find out the potential, the resistance across X and Y, which was supposed to be found in the question. We can use the following method, which is V1 is to V2 is equal to, V1 is to V2 is equal to R1 is to R2, because these two are in series, 3 ohm and the effective resistance of X and Y in series. So in series the current is same, so the potential will be of ratio R1 is to R2. I think I made the mistake again here. V1 is to V2, this is. So we know what is R1, which is 3 ohm, and we also know we don't know what is R2, which is what we have to find. So I'll write it as RXY, which is V1 is to V2, and V1 value is 4.5 and V2 is 1.5. So using this, I can find out the value of V1 as 3 upon the total resistance 3 plus RXY into the total voltage 6, which shall give you 4.5. I have simply used that ratio rule. 3 divided by 3 plus Rxy into total potential will give you the potential 4.5. So this is 6 3 is 18 is equal to 4.5 into 3 plus Rxy. So 4.5 into 4 times actually will get cancelled. Then you have Rxy plus 3 is equal to 4, and simply the value of Rxy becomes 1 ohm. So the resistance across X and Y is 1 ohm, which is actually the parallel combination of bulb as well as this external resistor R. Hence the answer for equivalent resistance between X and Y is 1 ohm, which is option 2. Thank you.